So how many of you are here that are working on protein? No? One? Protein. Oh, okay, yeah, you are actually the initial stage. You have finalized which topic you are going to select. So, as my area of expertise are enzyme engineering. So, I was working as an assistant professor at NIPG under IPFT, and now I'm currently working at Genome Center, and where I'm working on microbial genomics. And my background of research is related to enzymes. Okay? So on the basis of that experience, I will try to give you the troubleshoots that you will face during the when you will work on proteins. Okay? So so you are familiar with the word protein. Okay? So what do you think, then why should we purify a protein? Or is there any way that we can, without any purification, we can go on and study our protein, or we have to purify it? Any idea in your mind? Oh, yeah. Anyone else? So you are saying that there are multiple proteins in a mixture. You do not know where your desired protein is. Okay. Well, there are certain techniques in which you actually identify the proteins. For example, if suppose I am working on a particular enzyme, okay, let's suppose it's an extracellular enzyme, suppose it is cellulase, okay. So it's present, suppose, in the crude state, or it is not purified. What we do, as we know that the protein is present in that mixture, we do an assay, enzyme assay, and based on that, as enzymes are specific towards the substrate, okay. So these enzymes will react with the desired substrate. For example, in case of if the crude contains cellulase enzyme, when we react it to its substrate, which is cellulose, so in lab we actually use the derivative form of cellulose, which is CMC, carboxymethylcellulose. So once we react under the standard conditions, assay conditions, the enzyme will react with that substrate and give a product. So by that we can quantify the activity of that particular protein. Okay, so in the mixture, so if we have we have the substrate available for that type of protein. For example, this is an enzyme. We can, in the crude state, we can also study that. Okay. So for example, at NIPG, we were working on fiber degrading enzyme, and we were not purifying that. Just we were doing filtration, and we were getting the crude form of enzyme. And this crude of enzyme contains the fiber degrading enzyme, cellulases, xylanases, pectinases, so on. So this enzyme was then was sold to a local pharma. So we were producing these enzymes at a commercial scale, and it was not in a pure state. So it is not always the goal of protein research to get the pure protein. So you may also work with the pure protein. So okay. So by actually when you purify that, you become more specific in that. So by doing so, you can actually clearly establish a particular biological activity. For example, you can also purify that enzyme to when, for example, you want to study the kinetic of that particular protein, then it is requirement of if you are focusing on a pure enzyme. So you have to study the kinetics of that enzyme, then you have to purify it. Okay. So what we when we were working at NIPG, we actually were first dealing with the crude enzyme. We were characterizing the enzyme. Okay. Then after characterization of crude enzyme, we were purifying them, and then again we were characterizing them, and then we see the differences there. So for kinetic purpose, you have to purify these proteins. Okay. Okay. So now, if your goal is to study its structure, then automatically you have to purify that enzyme. Then, if you want to sequence that protein, then you have your goal will be the purified protein. Then, if you are working on antibodies production, so it's a fine chemical. Now, for example, if you are using a particular protein for drug purpose, then it should be purified. Okay. Okay. So the rest of point I have discussed is all inhibition or activation. You can study. It comes under kinetics of the protein. Okay. Now, what will be the first step towards studying the protein or purification of protein? So first, your goal will be which target protein you are purifying. For example, if I am working on a microbial enzyme, so first of all, I will produce the desired enzyme, okay, through fermentation. This will be the first step. You will do fermentation. So before that fermentation, you have to optimize the fermentation condition for that. So this is a different topic. Okay? So I will not go into that detail. So at the first stage, for example, in microbial case, you will go optimize the fermentation condition to get the maximum yield of the desired protein. Okay? As mentioned earlier, that in the crude state you can also target that enzyme. So you can optimize the fermentation conditions through this, using the crude enzyme. Then after what you do centrifugation. Now when you do centrifugation, you will get two things: supernatant and the pellet. So the pellet contains cells. The supernatant contains proteins, extracellular enzymes. Then there comes two things. One is that intracellular or extracellular. So the intracellular will be in the cells. So if you want to study that, then you have to discard the supernatant and use the pellet. If you are using extracellular enzyme, then you will use the supernatant and discard the. Okay. So to the for example, if you are working in an industry in which the enzyme is required in bulk, and these enzymes are actually cellulase, ironase, so on. So these are produced extracellular; they are produced in bulk. When you are working on, for example, enzyme tech polymerase, it will be produced inside the cell. Okay, so it will be produced in very low amount compared to that. So for extracellular protein, what we do after centrifugation, we get the supernatant, and then to this supernatant we add salt, ammonium sulfate, to precipitate out the protein. Okay, so in what way we can concentrate the protein? By precipitation, by ultrafiltration, okay, dialysis and centrifugation. Okay, so in ultrafiltration you actually take the cutoff value based on the molecular weight and use filter that protein. So the protein to which you can concentrate the protein as of your desired interest. Okay, and then after precipitation, you have precipitated the protein. The next phase will be to remove that the salts, the ammonium sulfate salts that are present with the protein. Okay? So what happens that in the next few slides I will show you how the precipitation works out on protein. Okay, So after precipitation, what you do, you centrifuge the that sample again. The sample which you have treated with ammonium sulfate, after for about 24 hours, placing that sample at 4 degrees centigrade, you centrifuge that sample again, and because the proteins are precipitated out, so the protein will pellet. After centrifugation, you get the pellet that will contain the desired protein. Okay? Then the next task is how to remove the salts from the protein. Dialysis. Okay? So by dialysis, you can remove the salts from the protein. Okay? So in each these steps, when you are working on a protein, it requires optimization. The same protocol will not be govern all the proteins. So when you start with a protein, every step in these purification process is optimized. Okay. So then for purification, after you have removed the salts. Okay. Now because of the dialysis, the protein may be diluted if the protein is an intracellular, for example. Extracellular, there will be no issue with that. You will get sufficient amount. But when it is enzyme that is producing very low concentration, then you have to use another technique, freeze dryer. Okay. So by freeze dryer, what you will get the concentrated protein. Okay. So after getting the desired protein of your desired concentration, now the next phase is purification. Okay. So what will you do after dialysis? If you get the protein, and then you will use the ion exchange chromatography, or size-exclusion chromatography, or affinity chromatography. So you will use these techniques to purify the protein. Okay. So in my lab where I was working, the steps that were taken for purification was, the first step was dialysis, then freeze dryer, and the next step was, you can also do that if you have the protein, you just concentrated it into the freeze dryer. Okay. When you get the concentrated protein, you can then purify it without addition of salts. So you can remove the salt steps in the purification step. So you can directly freeze dry that desired sample, and you will get the concentrated protein. Okay. After that, you will purify the protein using ion exchange chromatography, size-exclusion, and affinity. So in my lab, in NFG, first after concentrating the protein, we were using size-exclusion chromatography, then ion exchange chromatography, and after that affinity chromatography. Okay. So during each these purification steps, you have to check the proteins that did you get the desired protein at the required purity you are interested. So you can use a number of electrophoresis methods, and by running the gel, you can identify that the protein is purified or not. Okay. So first you go to commissioning, then then you can go silver staining. So silver staining is more sensitive. So if the protein concentration is greater than 100 microgram, okay, you will use commissioning. Okay. If the protein concentration is below 100 microgram, then you will use silver staining. Okay. So silver staining more. So by observing that, you will the base you can predict whether this is a pure protein or not. Okay. So okay. Now using SDS stage or electrophoresis, you can actually qualitatively quantify the protein. Okay, you see the protein, but you cannot predict what is the concentration of that protein. So for that you will use protein assays, Bradford methods and Lowry method. Okay. So any of you have worked during your MSc related to these techniques, Bradford method or Lowry's method for detection of protein? What about that? No. Okay. So these two methods are used for the quantifying the protein in the particular sample. Okay. So you will get the protocol is available on internet. You will get that, and for that you have to optimize again. When you are working on your protein, you have to optimize each step of these the reagents used in these methods. The methods using in these methods will be optimized. After that, you will get the desired results what you want. Okay. So enzyme. If a protein is in enzyme in nature, then you will do enzyme assay. As mentioned that previously, that the enzyme will be reacted with the substrate, the product will form, and based on this, you can quantify the how active is the enzyme. Okay? By reacting the enzyme with the substrate, how much by the reaction you can get the activity of that particular enzyme. Okay? So I have already discussed these points with you. Okay. This stage, you are working with a fine chemical that is using pharmaceutical, or you are using for example, you are requiring Crookes test. So it depends upon how much you want to purify the protein according to your needs. Okay. So when we are studying protein, for example, for commercial purpose, then the steps involved in the process will affect the final product cost. So when you are working, when you are adding purification step in that in the process, actually the end product will will be increased. Okay? So for certain cases, for example, where I was working on fiber degradation enzyme, we were interested in cocktails of enzymes that were involved in the fiber degradation. So it was not single protein required; it was multiple protein enzymes. So by doing so, we were getting this enzyme was using poultry feeds. Okay? So we were actually producing that enzyme, and we were selling it to Exino Pharma. It was a local pharma in Lahore. So we were selling these protein to the pharma industry. So they were then selling to the poultry feed. So we have optimized all the production conditions at our institution, and we were producing at our fermenters. So we were not, they were not producing, we were producing. Just they were selling out. So the fermenters were for the budget required for the fermenters were given by the local farmer. So we were producing it in our institution and giving them to the local farmer for their sell-out. Okay. Okay. So these are the two. One is the dialysis. This is the filtration. Okay. So in dialysis, what you do, you have it's like a dialysing tube. Okay. They go dialysing tube. So they are of different cutoff value. So before using the dialysis, you should have the knowledge that what is the molecular weight of your desired protein. Okay. On the basis of that, you select the protein. For example, my protein is 14 kDa. Okay. So what I do, I will use 12 kDa cutoff value. So I will use larger than that of the pore size of that the tube should be less than. Okay. So in dialysis, what happens that when you add ammonium sulfate to the sample, okay, what happens that ammonium sulfate ions will bind with the protein, with the water molecules, okay, and because of this it will dehydrate and the protein will precipitate out of the solution. So what happens when you dissolve something in something? What happens? They actually interact with each other. The ions will interact with each other. Okay. Because of this, it will decide whether it will be dissolved or not. Okay. So in this case, what happens that the water molecule that were previously interacting with the proteins, now they will interact with the salts. So they have more binding affinity for the salts rather than the protein because of the charge. I will not go into the chemistry of that. Okay. So because of this, the protein will precipitate out. Okay. And after precipitation, now there will be two phenomena that will occur. If you add more salts to the solution, okay, so the protein will precipitate out. So you will tell that this is salt out. So then the next is salt in. In this case, what happens? You actually remove the salts from the protein, and this is called salting. Okay. Now, how will you remove the salt from the protein? Okay. So for that, you have to use a buffer. A buffer that is in that buffer the desired protein is stable. Okay? So proteins are very sensitive. Some proteins, some maybe can bear harsh condition, but most of them are very sensitive. So they work under mild operation conditions. So when you change the conditions, the protein may be denatured or may not perform its function. So in this case, what you do, you actually use buffers. Okay. For example, if my desired protein is active in pH 7, so I will make the pH 7 buffer, and then I will take the dialysing tube. Okay. I will place my concentrated sample, which I have previously concentrated using ammonium sulfate precipitation or filtration. Okay. So what I will do, not ultrafiltration, just salt, the ones which we have treated with salt. For just filtration, we will not use dialysis because we have already we have not used salt in that. So the goal of this is to remove the salts from the mixture. So then you will place this dialysis tube in a buffer. In this, for example, this is the buffer. So this is the protein in the dialysing tube. So after for protein, when I was working in proteins, I was making these dialysis samples at 4 p.m. and I was placing this for overnight. And next day at 8 o'clock, I was taking the sample from this after dialysis. So the dialysis time I was using was from 4 p.m. to next day 8 a.m. Okay. So now because of this, you know that the water will move from higher concentration towards the lower concentration. Okay. So because of this osmosis phenomenon, you will get a protein inside in this tube. Our rest of the salts will remove out. Okay. So what happens that it is not always the case that you will get the protein which is you may get some salts in there, so you will purify them. Will purify in the later stage using ion exchange chromatography. Okay, so by dialysis you cannot get the complete removal of the salts from the sample. So we use what? You will size-exclusion chromatography, then ion exchange, then affinity. Okay. अच्छा इसमें one thing is important है कि when you are making this sample, you have to keep in mind that the amount of this precipitate you are adding to the tube should be such that there should be a space for that, as overnight the water will move inside the tube. So if you have loaded a higher amount of protein in a very smaller space, what will happen? The next day you will come, the tube will burst. Okay? Okay. So after that you get the protein. Now you have you get the desired protein. Now there is another method in which you can do the precipitation of the protein. You get the protein by using centrifugation method, and in this method you make a gradient of sucrose, and using ultracentrifuge, the protein according to their density they will separate out. Okay, so by using the ultracentrifugation and using the using the sucrose as a gradient, we can also separate out protein based on their density. Okay, gradient. So this is the diagram showing the size-exclusion chromatography. Now what happens that in size-exclusion chromatography you have this column. This column contains matrix or beads. Okay. So when you add, so first you optimize this, calibrate this tube with the with your buffer. Then you load the sample on top of this column. Now based on your size, the protein will separate out. Okay. So what you think, which one will be come first out in this sample? The larger one or the smaller one? Larger one. Smaller one. How many are saying larger ones? Smaller ones. Yeah. इसमें जो आपके लार्ज साइज वाले होंगे वो पहले आएंगे. You know why? Yeah.
Because sir, इसकी जो बीच के अंदर है वो बीच बहुत छोटी है, इसमें लार्जर साइज वाले इसके अंदर जाएंगे, इसकी वजह है.
Because when you add the sample, the smallest particle, the small size particle will diffuse inside these beads. These are porous in nature. Okay? So the larger one will just take these pore size, because of their size will use first. So the larger molecule will become first out. Okay. So at this stage you can get rid of the salts. Somehow a little amount of that salt is remain in the sample after dialysis. You can the salts will elute out, and you will get protein that will be free of any salts. Okay. Okay. Now in ion exchange chromatography, what you do? You do based on the charge. Okay. So these beads, instead of using their porosity, what we use the charge on the surface of these beads are used for the separating out the protein. So what will happen? The protein will bind to these beads. Okay, your desired protein. Then by changing the pH or salt concentration of the buffer, eluting buffer, you can get the desired protein. Okay, so first you actually then calibrate the beads. Then after calibration of the beads or matrix, you add the desired protein. They will bind to this to this matrix or to the beads present in the column, and then you will slowly increase the pH or salt concentration, and based on their affinity to the bead, they will elute out. Okay? So by doing so, you may get the protein. So at the first stage, you have run on size-exclusion chromatography, then you have run on ion exchange chromatography. You get the more pure protein, and the next phase is using affinity. Okay, where's the slide? Affinity. Okay, this is affinity. In affinity, what you do, you know the protein structure, okay, and you know that where we can bind something like that. Okay, so what you do, you make the beads. Instead of using the porosity or charge of them, we specifically bind particular binding site for the protein. So the protein will bind, the desired protein will bind to the beads, and the rest of the protein will elute out. So the next thing is then you will change the buffer or pH, and then you will remove the protein on there. Okay. In affinity, for example, if we are using, mostly what we do, we clone the protein of that particular protein you want to study in a particular vector. Then you transform into a E. coli or a yeast, and when you are sequencing, when you are cloning the gene, you actually add certain types of histine amino acid that are that will produce color, not color. We will take a sequence. For example, this is a gene. Okay, we will add histidine. We will link amino acid sequence to this, which is responsible for coding for histidine. So this histidine is then used for binding of affinity. Okay? So when you are working on a protein, if you want to study the affinity, then you can do that by cloning the desired protein in a particular cloning system. Okay? Okay. So you are, as previously mentioned, we can qualitatively quantify the protein. So by using gel electrophoresis, we can study is this the protein pure or not. For example, if this is the ladder and the sample gets only one day, it means that it is a pure protein. But it is not always the case. But most probably you will get the protein. Maybe possible that this is a band that contains two proteins which have the same molecule. Okay. So for that purpose, then you will Western prodding or something else. Okay. Or you may go for isoelectric focusing. Okay. The 2D. Okay. Okay, so the next will be related to your practical. So after lunch you have to come to the genome center. So we will do practical.
After lunch today, I think Dr. Ayaz has that after lunch he will have
Okay, so you think? It will not long, it will be half an hour or something, just have to do it on okay? If you are interested, we can arrange tomorrow as well. Yeah, then you message me a contact, I will arrange. It will not a long class, it will take half an hour. Okay? So any of you are interested in studying the proteins? Okay, which protein? Enzyme. Protein. From which source? Microbial source. Okay. Then? Lysozyme from egg white. Okay. So what we can do first is purification of that. So what we can do, we can add salt to that. Then the protein will separate out. The next phase is what enzyme you are talking about? Lysozyme. So the next will be to test whether it is showing activity or not. So for that you have to identify which.
So what is this precipitate egg white?
Yeah.
So already it is in fermented form.
Yeah. Precipitate, for example, if you may dissolve in a buffer certain and then go for that. Yeah. You can skip that. You cannot add salt to that. You can direct go for centrifugation. Yeah. Okay. 2:30. Okay. 2:30. So when you are working on particular protein, what you go at the research papers that are working on that. So you take different methods to which the people have worked on. So there will be not a single method; they will be different. So by using them, then you can optimize your own desired protein. So initially, whatever your target protein is, you go on the net, study what previously have done, and using this information, you can design your own setup. Okay? So my work is totally based on microbial enzymes. Okay? So there are multiple ways to approach your target. So the first will be go and see how many research articles are released in the good journal, and then collecting these methods, then you can use any of them and check which one is the best. Okay? So you will, at the initial stage, you will use multiple techniques to reach your desired goal. Okay? Okay. Okay.